Hey team, I'm Maddie. Welcome to Science Side Up, and today we are talking about potential temperature. Potential temperature is a way of measuring temperature that's unaffected by adiabatic processes. What in the world does that mean? When we learned about the ideal gas law, let's think about that, get that little equation up in our heads. We learned that temperature can change just from the change of pressure, not because we've actually added any heat or energy to the system. We've been referring to those processes that can change temperature without actually changing the energy of the system as adiabatic processes. Temperature, when it's only changing adiabatically, isn't really interesting. That's not something that's going to drive dynamics. That's not going to do a lot of things. So what scientists and meteorologists have come up with is a new variable called potential temperature that we often use instead of temperature, because potential temperature doesn't change from adiabatic processes. If you're going to change potential temperature, you actually have to add energy to the system. In terms of everyone's favorite magical balloon, let's think about raising this balloon from the surface way up into the atmosphere following the dry adiabatic lapse rate. Then we'll define potential temperature so that it is constant inside this balloon following the dry adiabatic lapse rate. Mathematically, that equation turns out to be potential temperature, which we generally represent as the Greek letter theta, is equal to actual temperature times a reference pressure divided by actual pressure and then raised to this R over Cp. R is the dry gas constant and Cp is specific heat capacity at a constant pressure. These are both constants and I wrote the ratio down. So these constants, R over Cp is just 0.286, it's unitless, and initial pressure, our reference pressure, is 1,000 hectopascal. That's roughly surface pressure. And then one last note is that temperature here is specifically in Kelvin. If you use a different unit, even Celsius, this will be wrong. This is potential temperature. It's defined so that it is a measure of temperature that is constant under adiabatic processes. And honestly, it's very, very useful. I use potential temperature way more often than I use regular temperature when I'm doing like science and research and things like that. Obviously, regular temperature is better for communicating to the public because that's like, how hot is it outside? Potential temperature isn't the best way to measure that. I do want to note that potential temperature will change if we follow the moist adiabatic lapse rate because there's that latent heating going on inside the balloon for moist adiabatic lapse rate, and latent heat is a diabatic process. So potential temperature is only constant if we're following the dry adiabatic lapse rate. This is the next big question. How does potential temperature change with height? Because we know how regular temperature changes with height. It drops because of the drop in pressure, but potential temperature doesn't change because of a drop of pressure. The short answer is that if absolutely nothing else or nothing interesting is going on, then potential temperature is constant with height. But that gets us into a concept called static stability, and that's going to be the topic of our next video. So I'll see you guys there. Okay team, that's all I've got for you today. I hope you liked this video and I will see you all in the next one. Bye team. There's a plane flying overhead. I don't know if y'all can hear it, but I can. It's almost gone.